All right, yeah, we are going to resume in a minute. Yeah, feel free to actually find your new seats and then just waiting for the next session. All right, yeah, I guess everyone can look at the screen now, so you see a picture. I guess this is actually a picture. Normally, I think at a conference like this, I always want to show to people. So since we have actually community building up, we have lots of seniors and lots of juniors. And then this is the picture typically I want to highlight, especially for the juniors. When you are in the conference like this, try to avoid following your supervisor, your boss, like this. So yeah, you better actually talk to the other ones rather than always chasing your own boss and losing the actually opportunity for the networking opportunity. And then so this is actually just one thing to highlight for today. I hope everyone in the end will actually have new connections, new networks, rather than actually only with your small network of your supervisors over the whole days. Yeah. So in the end, I want actually this pile of docs talk to the another pile of docs rather than always with your supervisor. So thank you.
Yes, great point. Okay, let's start with the first panel on Power Grid Cyber Resilience. The first speaker, if we can go to the next slide. Oh, of course, scan this first so you can submit your questions. Okay, so. Not going up. Okay, oh, sorry. Okay, so our next speaker is Saurabh Talwar. He's the Global Product Manager at Siemens for virtualization and protection. So Saurabh, the floor is yours.
Yeah, thanks a lot. Okay, test, 1 million, 2 million. Okay, so I'm the global product manager at Siemens in Germany, focusing on virtualization. So I'll focus this whole talk around virtualization and how cybersecurity ties into this whole concept. Yeah. I was actually at an event in Norway and arrived at the event roughly around midnight, and I couldn't sleep. So I enabled ChatGPT on my phone, and I enabled voice on it. So and I asked, what's the next evolution for digital substations, which is protection in secondary substations, but it understood sanitary substations for some reason. But I was surprised that it understood the context. It says, okay, hey, I think you're talking about secondary substations, not sanitary substations, which is great. And I was really surprised in the outcome it gave. So it said we started with whole legacy electromechanical devices, we went to numerical devices, we went to smart meters, and the next generation is virtualization, focusing protection and control as software and focusing on AI as edge applications. Yeah, and that's exactly what I'll be talking about. Yeah, so if ChatGPT can predict it, I'm sure it will happen very soon. Just a couple of things. So virtualization, it's a technological term. Yeah, so behind this term, there are two main technologies: containers and virtual machines. Yeah. But it's a technological term, yeah? There's a lot of buzz around virtualization in our power grids and OT space, which is great, but that's not where the focus should be. The focus should be in the customer benefit it brings, yeah? Which is high-level benefit. We're talking about centralization. And we're talking about not only centralization for 2 feeders or 5 feeders, we're talking about the entire digital substation. So if it's 20 feeders, if it's 50 feeders, we're talking about centralizing the whole landscape within a substation. Okay, just to high level explain the big difference between virtual machines and containers. Yeah. So virtual machines, you will still have a hardware computing platform. On top of that, you have a host operating system, and then Then you'll have a hypervisor. So hypervisor is just a fancy software term for orchestration, yeah? On top of that, you will host your protection and control applications, yeah? Now, in contrast to containerization, you still need a hardware, you still need a host operating system. You will need a container engine, which is just a fancy term for orchestration. Yeah, it's just a piece of software. And then you host your protection applications directly on the operating system level. Yeah, and the best way to explain containerization is just like your iPhone. Yeah, your phone itself is the hardware server, and then the apps that you see on your phone are pretty much applications for protection and control. Yeah. And that is exactly what Siemens is focusing on. We're trying to build kind of an app store, like an Apple iPhone, where we can host all protection and control applications on it. Yeah, and we are scaling at an application layer, and we're not scaling at a hardware layer anymore. Yeah, and that is the whole idea. Okay. Okay. So this whole concept, I get a lot of questions from the industry. Is this whole solution an IT solution, or is it still an OT solution? Yeah. So the OT solution is talking about operational technology. Yeah. Now, even though we are using an industrial PC or a server-based approach, that by default doesn't classify it as an IT system. Yeah. Treat the whole system as a big embedded IED box, and we're hosting all software applications on it. Yeah, so we still classify this as an OT product hosted in a critical substation environment, and it is not an IT system. Yeah. Okay, so I had the privilege of working with around 12 customers around roughly 3 years ago, and I sat down with them to discuss what are the current challenges they're facing and how virtualization can really help. So the conclusion is what I'm presenting over here. So the first main topic is there's a big pressure to increase grid capacity. Yeah, so everything is getting electrified. There's a big digital expansion concerning AI, and the last statement is something that I get a lot from customers. Yeah, they say we need to double grid capacity in the next 10 years. How to do it? Nobody has any idea. Yeah, but it needs to happen, which means that what has been built for the past 50, 100 years needs to be done in the next 10 years. It's an impossible task unless something changes. Yeah. The second topic is modernization pressure. We all understand the whole infrastructure of power grids is aging. There's a strong need for standardization and automation. Yeah. And again, the last statement is something comes a lot from most of the customers. We need to start rolling things out much faster. Yeah. Today, it takes us 2 years, 3 years to do a project, just one substation. With that pace, there's no way we're going to meet the expectation to double grid capacity. Yeah. And the last topic is something a lot of people forget, but it is a big topic, I would say, which is the people factor, as I call it. Now, we all understand that there's a lack of expertise in our industry, and there's a big transitioning workforce that is taking place. Yeah. So the existing generation is going into retirement, the younger generation is coming in, and there's a big user expectation change. Yeah? And this people factor, if I'm really honest with you, it's 80% of the whole equation. Yeah? There's people, there's processes, and there's technology. And the people is the biggest piece. Yeah? And it needs to be handled right. Okay, so what are we doing in Siemens concerning this? So we are very product-oriented as of today. So in a substation, if we have to deploy equipments for 20 feeders, we provide embedded IEDs for those 20 bays, for example. Yeah. So we are very product-oriented. And what we are doing is that we are trying to decouple this whole story. So every embedded box has a software application plus an operating system. We're trying to take the application layer out of the embedded boxes, and we're trying to host them on an industrial PC or a server-based approach. So we're going away from product approach to more of a software-defined solution. Yeah, and that is the whole concept of virtualization. Yeah. Now, our idea is to take 60 IEDs and host them on an industrial PC, and then you can have a backup system of it. Yeah. So what does this really mean for a customer in a digital substation environment? So you have a process layer where we have merging units, what we call, which are sensors, which will gather all the information and transmit the information to the field level, yeah, which is embedded boxes today. And this information, the information from the embedded boxes will be transmitted to station level information and then all the way to the control center, yeah. What is changing with virtualization is this entire field layer. So if we are so used to building 20 panels for 20 bays, we have to build now only 2 panels in a substation. Yeah? So less panels, less building size, better sustainability story. Yeah? Okay, so how we are deploying this whole solution very quickly, high level. So we have a computing hardware system, which is substation grade. Yeah. On top of that, we are going with Linux operating system. We don't want Microsoft or Bill Gates in our substations anymore. And that's a statement we get a lot from customers. So we're going with Linux, less patching, less updates, a better maintainability story. On top of that, we install our software packages. Yeah. So this is just to show that, okay, everything that was physically embedded oriented, we are taking the same thing, but we are representing it in the software world. Meaning the Baywise concept still applies, but it's virtually and software conceptually done. Yeah. So if customers are so used to taking a bay into service and doing maintenance on it, the same concept will apply in this whole software landscape. Yeah. So on top of that, we'll have a web UI for visibility, so you can do controls and you can monitor the entire substation. And then from an engineering standpoint, we're using our existing tools when it comes to Siemens, it's Dixie, and we're going to use the existing engineering landscape to configure this virtualized system. Yeah. Okay, so virtualization benefits. Yeah. And these benefits have been collected from the market, from customers directly. Yeah. Now, the first topic is the customers want to make sure that there's total lifecycle cost savings. Yeah. Now, instead of handling individual boxes and different hardware variants, now they need to only handle 2 servers, for example. Yeah, less asset variants, less assets to manage. The expectation is that this should result in lifecycle cost saving. Yeah, and the expectation is that this should result in roughly 20% of savings for the customer. Yeah. Easy manageability. I think I've alluded to the fact that, okay, so less hardware variants, yeah, so less assets should help in maintaining the system much better. So that is covered under easy maintenance. Comprehensive pre-deployment testing. So this is a big benefit of virtualization. You can take the exact same configuration copy of your substation, put it in your back office environment, and you can test your entire digital substation. Yeah, and once you're satisfied, you can push that configuration back to the substation. Yeah, so the amount of testing you would need to do at site is very limited. Yeah, and this is one of the big drivers for virtualization for customers. Yeah, flexibility. It's software. It's just like an app store. You download an app, you can delete it. So the same concept and flexibility should apply in this whole concept. You can download software applications, features, install it. You don't want it, you take it out. Yeah, so there has to be that customization for the end customers. Enabling AI. Siemens is actually working on an AI application. But this is only possible due to virtualization. Now we have the computing power, we have the resources, it's all software. It's easy for us to host now complex algorithms like AI in a live substation. Yeah? The goal is to make substations much smarter than they are today. I will skip this lifecycle management. It will take me much time to explain this. I know I have a clock to give this presentation on. Last topic, sustainability. Yeah, I said less panels, less building size, which means less steel, less concrete, a better sustainability story. Yeah, and this is one of the big drivers considering a lot of companies have a sustainability roadmap in their companies. Okay, virtualization benefits, great. How does it relate to cybersecurity as well? So I will quickly touch on this. Virtualization is about hosting your application in an isolated environment. The more isolation you have, the better the security concept. Yeah. The other topic is access control. Yeah. So the more you contained, you can control the access, and when you're centralized, you can control access control for any data system or networking. Yeah. Monitoring and responses, it's easy to monitor in a software landscape, so you can actually figure out if there are any threats in the network. Recovery and resiliency, you can recover your system much faster because in a software world, you can take snapshots and you can clone the system. Yeah. And I would say tooling makes it easier for us in this whole virtualized landscape for cybersecurity, and we can definitely do microsegmentation and zero trust policies in this software landscape. Yeah. And lastly, we are working with TU Delft on a control room of the future, and we're working very close with Alex. And Alex mentioned that already, so I will skip this part, but just wanted to mention that we are extensively participating in this whole landscape of building what's the future of digital substations. Yeah, and I will conclude it over here. Yeah, so my side.
Thanks, Arab. Drop your questions, please, online. And now our next speaker is Jeroen van Duren. He's from Tenet, asset specialist on working on cybersecurity. So, Jeroen, what is yours?
Thank you very much. Ooh, even my soft G sounds loud through this system. So, hello world, my name is Jeroen. I work at Tenet, which is the transmission system operator of the Netherlands and a large part of Germany. And my role is that of asset specialist in cyber resilience. So I can do a lightning talk because most of this has been already covered by Anjos. Thank you for that. This is the European grid, one huge and awesome interconnected system, interdependent also. Tenet has a large part of Europe, well, at least a large part of Germany and the whole of the Netherlands for the extra high voltage network and the high voltage network. And in the Netherlands, which is the focus of my presentation and my work, we do the high voltage and extra high voltage networks, including very cool interconnector systems, the very first ones in Europe even, at least overseas. Okay, so this network is controlled physically by substations, like this one. There's a lot of big components which are controlled by small components. So these are the big components. This is the thing you can actually see in outdoors. You have the switches, you have the disconnectors and the circuit breakers and stuff like that. That is all controlled by old stuff like this. This is secondary equipment, mechanical relays. I must say, some people in this room, for some people in this room, this isn't as very old, but this is the new variant. Even newer is the VPAC system that Siemens just presented. And that all depends on auxiliary systems for power supply, for fire suppression, that kind of stuff. And this all is also going from mechanical to digital, everything. We do the same, but then offshore. This is also just a substation, but in a big yellow box. And this all, well, as I said before, is going from mechanical to digital. Of course, Siemens. Yeah, I must promote my research partners here. And this transition to digital makes it so that the electricity grid is one big cyber physical system. So this is a representation of a substation in a single line diagram. But it also has a network diagram which connects the secondary systems digitally. And over these networks traverse all kinds of protocols. And these protocols all have data models. So this is the 61850 data model, which we use to control secondary equipment in the substation. And you can imagine that this makes what used to be quite simple, which you could control with a screwdriver and a multimeter, quite complex. Just like the car industry, we have to move from purely mechanical systems to thinking in IT terms. Well, and this all also introduces a very large attack surface, especially if you don't understand what you're doing and what the consequences are of you connecting digital systems to each other or to a network, or even to the internet by accident. Luckily, There's a lot of laws, regulation, and standards that can help us, form a basic security level. However, security is not compliance. Well, compliance is not security. Compliance is a way to do your due diligence and to cover your ass, but it is not actually securing our systems. So at Tenet, we do compliance, but we also do system security engineering. So this looks quite complex. It's actually quite easy. We take into account the context of a system that we are designing. We're looking at what are the protection needs. Well, I shouldn't say protection because that's electrotechnical, so we say resilience needs. And then we do the risk assessments and the right measures, countermeasures, to actually protect the system in a way that it isn't overprotected, so you can still work with it, but it certainly isn't underprotected. Because, like in an electric circuit, if you have too few of resistance, you get sparks and things go boom. Same for cybersecurity. But if you have too much resistance, the current will find the shortest other path that's available. And that's the same for our people. So if we make things too hard to work with, they will find other ways around the system. And that might also compromise security. One of the so we have a few principles that we apply. So we do defense in depth. We do security by design. So security should be implemented by the very first moment that we think of introducing a new system. And things like simplicity. So I must say Tenet isn't ready for virtualization yet, because the primary thing that engineers do is keep systems as simple as possible, but not simpler than that. And the electrical substations are actually very simple systems, very old systems. That's why we have to design our defenses mainly around those systems. We cannot simply update those digital systems rapidly because it's a running grid. Yeah, and it's quite difficult to take systems offline, patch them, and take them online again. So we have to design our defenses around those systems, which is called defense in depth. And we need it because there's a lot of emerging threats in Europe, especially right at this moment. Hybrid warfare is one of the biggest concerns we have right now. And that's why we like to work together with the TU Delft. The TU Delft helps us explore new threat vectors. It helps us explore new countermeasures. We can simulate these countermeasures and look at the effects on the grid as a whole using the digital twin, the RTDS, the simulated grid. So we're really happy to work together with the TU Delft to actually simulate security, both attacks and countermeasures in a safe environment. And we can also, because it brings together several partners, so it's not just Tenet and TU Delft, it brings together a whole ecosystem of partners. We can also profit from the knowledge of all the other partners we have. And that was my presentation.
Thank you, Jeroen. Now, again, questions, please drop them online and we will take them during the panel discussions. So our next speaker is Nuran Martin. Nuran is working at Steadiness Grid Strategy Control Engineer. Nuran, the floor is yours. So Nuran will present about the cybersecurity of distribution systems from Steadiness perspective.
Thank you very much for the introduction, Alex. Hello, everyone. My name is Nuran Martin, as announced. I'm working for Stedin But at the same time, I have a kind of double role, also being a guest researcher at TU Delft. And at Stedin, of course, we are developing policies around future energy systems. And for that, we need innovation to support our policies. And TU Delft is well positioned for that. So my talk will be about cybersecurity. I need to confess that cybersecurity is not directly my domain, but it's a very related domain because I'm working in the area of control. And so I will try to voice as well as I can some slides of my credits to my colleagues who prepare the slides. So first of all, I will start with what is operational technology, OT systems. When we talk about OT, then it comprises the hardware and the software systems to control and monitor the physical processes in the critical infrastructures. So we are operating electricity and gas networks as Stedin. So it's a critical infrastructure. And the operations are, of course, 24/7. And we need to keep our reliability levels as we always had, which is about 99.9996 or something like that. So in this, we have various zones of operations. We use such an architecture as we see on the left, on the right side. This architecture is based on PRC architecture, and there are 5 levels of zones defined, which starts with the basic level of control, and it advances into more like a supervisory control, like level 2, and level 3 then becomes operations and control zones coming together. And this is more the OT domain. But afterwards, what it comes is the IT domain, and that is more about the business and enterprise processes related domain. And on the top of that, then at a higher level, there's also the cloud environment and external zones. The idea is that who is responsible for which domain and which information can be shared with each other. So that's the key issue with that. And as it was also mentioned by other speakers earlier, the IT and OT alignment is a very important topic. So what we can allow, what we cannot allow, and how. That is a key question. So Stedin Telecom Network, I will talk about briefly. Stedin develops and operates its own fiber optic network within the designated service area, and it's also currently extending this infrastructure into Zeeland area, which is in the southern Netherlands. And a portion of this network is reserved for development and testing with some key partners. And it is also intention to improve our collaborations in the domain of telecom, also with TU Delft. Some current challenges for the cybersecurity. I think these challenges have been quite heavily highlighted in the earlier talks, but I can also emphasize the fact that the legacy systems and vulnerabilities, that's really a key issue because they are not built with, not foreseeing all the what would happen later on. And therefore, that needs to be taken into consideration. And other than that, the patching and upgrading of OT systems, that is an important challenge because of 24/7 critical mission that we have. So we cannot just stop the system and not test things. So we need some other environments who allow us, without interfering our operations, to do some innovations. So this is part of the current challenges that we need to address. And secondly, there's a growing attack of surface because of interconnectivity. We have a lot of distributed energy resources. It might be much easier perhaps to have many electrical vehicles to create an attack surface for the attackers, for instance. So we need to just investigate such scenarios. And other than that, not only the growing attack surface, but also the different types of attacks that we need to learn and share knowledge about. So we are collaborating with the Control Room of the Future Technology Center at TU Delft and with other partners. And so there's the digital substation there, which is 150 kV to 10 kV. And there's also a virtualization, which is in progress at this moment. And I have also 2 dedicated colleagues at the Control Room of the Future. They are spending their day every week, and then they are contributing to joint development with Control Room of the Future. And so with the various proofs of concepts, they are being tested. We learn from each other, that is the key. And the IT-OT convergence, which is the key issue, which level, so that's the battleground in the OT area. But this innovation center can also help us to think through these challenges that we have. And state research, I'm going to talk about which kind of research is ongoing in this area. So there's AI research with the digital substation and real-time dynamic simulators. And OT data spine, the data broker is one of the projects. And with the cyber attack detection. So AI is not only as a threat, but as an opportunity also to identify anything which is malfunctioning or deviating. So this aspect is being taken into consideration in the research. And other than that, we have edge computing infrastructure. There are some edge computing related projects which we would like to link also with the Control Room of the Future initiative. And finally, also the open source challenge. So open source mechanisms, they create some new learning for us, co-creations, but at the same time, how to deal with some vulnerabilities that also, it can also bring. And so this slide is much more my area, let's say. I'm also part of the TWIN EU project. And TWIN EU is a large project with 75 partners and 15 countries with a budget of 25 million. And there are 3 years of working together. And we are in the middle of the project, and we received good feedback also, not only stakeholders, but also European Commission gave good to go signal recently. And so the idea is to develop, of course, Mission Impossible, the digital twin of the European energy system. So this project gives more the first steps into how we can do it. So have some prototypes and test environments, how we can exchange data. Nobody knows what's going on the whole system. Everything is interconnected with the cascading effects that we can. That's a very good opportunity to analyze the cascading failures. And the main focus of this digital twin is 2 dimensions for the Dutch demo. One is a stability assessment, and the other one is a cyber security related assessment. And as you can see here with the architecture, this is also intending to be really at a higher level of digital twin, because of also incorporating the feedback loop from the cyber environment into the physical environment. So it's not only physical goes into cyber, but also the other way around is the intention. So this proof of concept we would like to also implement. It's a broader project in the Netherlands, Twin NL project going forward, hopefully. So this is all I want to express, and thank you for your attention. And if any questions, very welcome.
Great. Thank you very much, Nora. Again, please drop your questions online. We will have a nice debate. I've seen already very interesting questions, also lots of votes to your preferred questions. That's awesome. Now, our next speaker is Mike Scharenberg from Liander. He's the OT security officer, and he will tell us about cyber resilience of Liander distribution network.
Yes, thank you. So I hope you all hear me correct. I won't stand on that thing because I like to move, so sorry for the camera. I will tell you something about the cyber resilience of the Liander distribution system. You already saw that one of TenneT, part of Stedin, and hopefully this will give an understanding how we made our grid resilient. I do that with a short overview of how our digital system looks, the OT system per se, but also where the hinder is with the upcoming technologies, decentralized, what Anjas already talked about, the whole energy system as a whole. Short, which threat actors do we take into account, and the service that is changing, and we end with the collaboration because we don't do it alone, we do together with TU Delft, but also with all the other grid operators and entities involved. An overview. I think for most familiar, we are Liander, the blue part. We have electricity grid and a gas grid. If you look at the digitalization, most finds place at the electricity, but a lot is also going on the gas grid. Won't go into depth today, but more and more digitalization is also happening here. You can also see the other grid operators and TenneT, of course, just the whole Netherlands from a TSO perspective. This is an image I always like to use to talk about. It's a way of showing the smart grid. It's already quite an old picture, I think a year or 10 old, but it's quite actual still. If you look in the bottom left, we have the old school grid from supplier all the way to the households. Which is changing now nowadays is that you have a lot of other activities going on. We have wind farms, solar panels at households, electrical vehicles, and that makes it more difficult to maintain the grid, where first, back in the day, we could look as a grid operator just at our own assets. We now need to take into account all these assets as well, because we can nicely say, we have our grid safe, but if it's dark, no one is happy as well. So that's what we're trying. If you look more from a digital side, how do we do it internally? And the next slide will be more like the broader side. We have two data centers, one in Arnhem, one in Haarlem. So if you look from a resilience perspective, one can fill, the other one will take over. They're intertwined, they're connected to each other. We monitor them both with our own SOC operation center there. And we analyze, and even how can we predict, how can we make our grid better as a whole. Likewise, as Stedin, we have our own telecom grid that we get from Alliander Telecom. So that's disconnected from the IT systems. Till that part, it was all fun and games, because we can always say, okay, we detach IT from OT and we keep on going. The only issue is that with all these decentralized activities, we get more dependent on, for example, GoParks, other trading platforms, and we cannot easily say we only look at ourselves. So we need to broaden our scope. Another picture, I think it's quite a lot if you see it for the first time what is going on. But that's what I mean is we have the physical grid, that's the gray area in between and the low. Then we have our digital grid on top of there. Apologies, that's in Dutch. Didn't translate it to English. And with the digital grid, you already see that there's a lot of new things going on. You see this long finger here. adjusting. It's not just switching on and off assets anymore. We also need to adjust on how much percentage we want the current flow to keep going, not only at our own assets, but also at the assets of our customers to make sure the whole grid is in balance at all time. And here again, you see the monitoring coming back. And the dynamic contracts, that's something also, instead of everyone can get a connection, we have the capacity problem, the congestion problem. I think everyone knows the famous red maps of the Netherlands. Then we need to do that switching. If we look at the threats that's going on, a subset, it starts with the easy ones, of course. You always have employees that are a bit sloppy. Like, still, you need to take them in consideration, because if they have a lot of, high confidential stuff and they leave the papers around, that's not what you want, because then it's also on the street. This happens more often than you think. I think as a grid operator, we're quite aware of that. But if you look at other companies, sometimes I walk around in other companies and everyone leaves the laptop open and no one cares. Not as the way I hopefully think everyone in this audience does. Internal iris, someone that stayed there already for a long time. We also have it, people that working there for 20 years, for 30 years. But after a while, the integrity of the people, they will change if they get dissatisfied. So that's also one to take into consideration, because which authorization does these people still have? The Simon Script Kiddie, someone from his ethic, trying to hack us. Now, hopefully we can say, thank you. Hopefully we can say we can prevent them from joining or from entering our stuff. And then of course the one I think we're all trying to be resilient against is the Sam from out of state. He has the capacity, he has the money, and he has the urgency to do so. And this is an increasing geopolitically issue that we see, of course. And this is where we try to be resilient against. It's not easy, and it will follow from the following slide. Anjas already stole this one from me, unfortunately. The decentralization of energy, there's more gigawatts getting installed. Solar panels, electrical vehicles, heat pumps, and go on and go on. And this quite makes it difficult as Europe to withstand if it's the 3 gigawatt is the critical limit, what you need to do. But we're looking into it, and hopefully with all the parties involved here, we can harm ourselves to all these activities going on. And there's also a lot thing, because what you see in all the regulations is focused on the big boys out there, but not all the small things involved. And then my ending, the collaboration. Of course, what we saw in the previous slide with the 2 data centers and with our central OT systems, we want to check which issues are there, how can we protect it better, as well as a central OT part, but also a decentralized OT part. So we're looking at both sides, and hopefully also in the future with the IoT, but that's the next step, to also check what can go on there. And thanks for that.
Well, thank you, Mike. All right, now our next speaker, we have Zeki. So Zeki is associate professor in cybersecurity group, and he's been working on privacy and security.
Well, thank you very much, Alex. Zeki Erkin from Cybersecurity Group. It's a pleasure to be here. I heard about smart grids for the first time, or smart meter, in 2012. I had no idea. I was, mentioned by a professor in the high building. I just learned that Professor Peter Palansky joined in 2014. Alex Stefanov joined a couple of years ago, and I'm really impressed. After a little bit, 10, 11 years, this is an amazing community, and we are discussing the resilience and security of smart grids, thanks to many other people working on this field. I'm also a little bit ashamed because my keyword, privacy, hasn't appeared yet today. So I need to know my audience. Who are the scientific researchers here? Scientific researchers? Okay, nice. The rest are coming from the companies, organizations, institutions. Cool. Question to you. Are we using smart meters to the fullest extent? I need one person to tell me yes or no. Would you like to? Are we using them?
I would say no. Why? Because of change legislation. We know the famous moment when the Dutch smart meter laws were affected. Yeah, and that basically is still hindering grid operators to make the full use, and also the other energy system parties to make full use of the data that we can grab and more from our smart meters.
Thank you. You saved my talk. Thank you very much. Otherwise, I will go. Please cut me off when the time is off. Because in 2009, indeed, there was this legislation about the usage of smart meters. I do believe at the moment it's like every 15 minutes you can measure. But the core research I have done on smart meters, data aggregation, are about actually using the fullest extent, using the capabilities of smart meters. If you can use them, if you can measure the consumption on real time, what can you do? What are the business models that you can use? So that was my research point, and in 2012 I started, but it's not my core research because smart meters are not that smart. Microcontrollers with limited memory, they are not very computationally heavy, and I think the communication channel was at that time, it was like GCM, GSM messages and so on. But there's also one problem. If you observe the power consumption on the cable or listening to the communication, you can identify what has been done or what is being done at home. Showering, cooking, fridge open, oven open, or how many times you shower, is there multiple people showering? All those things are very scary. There were so many applications about, for example, creating apps for thieves by merging data. But at the end of the day, we want to use smart meters and do business and create new business models, but there are legislations and privacy issues and so on and so forth. So I am stealing some sentences. Privacy is an operational enabler, not only a compliance requirement. So my claim is we can solve privacy issues, compliance issues, and we can create new businesses, but for that we need to be a little bit more active, proactive in this sense. So Europe is very much advanced in deploying smart grids. I just checked on ChatGPT. Europe is pretty good in shape. The Netherlands almost close to 100% deployment. I don't know, but Germany is really lagging behind. There should be some flexibility rules. I checked yesterday. Some reports say that this will be doubled by 2030. And what is the last remark? The EU Data Act is effective. Anyone knows what that is? European Data Act. As of September 2025, ownership of the data belongs to the customers. They have rights. You need to provide proofs and legal documents. You need to actually record your actions to be used by the court and management or government. So I do expect, or everyone expects, that the companies, organizations will be busy with this kind of legislation requirements in terms of writing your activities. Funny story, the slides I've seen are very full, colorful, amazing graphics. But I couldn't see privacy in any of the slides. Have you used the other speakers, or did you notice any privacy-related challenge? Do you have privacy-related challenge apart from this gentleman in your organization? Okay, then I am doing really bad marketing today. So what are the threats? The thing is, smart meter is there, measuring power consumption, and maybe you can create communities sufficient, self-sufficient, or sell, buy electricity, markets, auctions, you name it. I was very excited about that many years ago. But you also, as a provider, you need to monitor what is happening in your network. The neighborhood, apartment building, apartment itself, you need to measure the load and so you can provide electricity when it's needed. But you need to do that in a non-intrusive manner, right? That's why we have the legislation in 2009. There are also some risks, internal manipulation and insider risks. I think some of the things are related to security, but it's also related to confidentiality. Collusion between the aggregator and the users. Has it ever been happened that the organizations colluding with customers to cheat? Do you know any story like that? This is one potential threat, but I have never seen it happening. But there's a potential. And of course, if you ever use machine learning and AI for your new business models or services, possibly there will be some risks related to training the model and running the model. And then you need to be very careful. When we talk about privacy, we always assume that it is personal privacy, like individuals, their confidential data. But privacy is a little bit beyond that. Privacy is about the control of the sensitive data, including your operational data. And machine learning models might need your data or history on the data, how you used it for your operations. So actually, privacy is related to confidentiality. It's also related to integrity and trust. We can have a definition, mathematical definition for that. And my claim is TU Delft researchers can help you to solve privacy, security-related challenges so that you can come up with new models, new business ideas, and deploy them. This is my journey. I started with data aggregation. You see 4 papers, but data aggregation is not my core research. It is actually multi-party computation on sensitive data is my core research. There's a lot has been done in the last 10, 15 years with my students, my team. The last one was from last year, Usenix Security, one of the top conferences, and we show that our algorithms for smart meters, for data aggregation and beyond, can be very efficient, such that you can deploy them in almost real time and also protect yourself against malicious active adversaries. So these are scientific terms. Possibly you heard once or twice. Malicious entities, they want to disrupt your services. They inject data that is not correct. They stop the computation. But after 10, 15 years, we see that our protocols that are, it was impossible to deploy 10 years ago in those smart meters are getting efficient. So you should talk to us more about new ideas. What will happen if you try to deploy this approach? Everything will be protected confidentiality. We use advanced cryptographic tools, encrypt your data, aggregate them. You can even deploy differential privacy if you are sensitive about the output confidentiality. But what is very interesting is when some governmental organization asks you questions, you can provide proofs. Even though you don't see the data, you can provide proofs that everything is done according to law and compliance. And of course, if you are interested in new ideas, like new business models for your customers, self-sufficient villages, for example, and to generate electricity using AI models, federated learning with privacy is also ready at the moment. So I will wrap up very fast. These are the steps you can do verifiable aggregation, and aggregation is a generic term. You can deploy also other operations. It will give you a lot of benefits. Why? First of all, you can provide to the government that you are doing your responsibilities very well, compliant. You can have new business models that's not possible right now with the existing running structure of the smart meters. And I don't know, privacy protected services maybe attract more customers. So my idea is, why don't you test our ideas in a pilot of 3 months or so on to see if my claim is true or not. So I will wrap up here. I just want to say that, well, if you're interested, please reach out to me and to the professors here, Alex and Peter Polansky, about this kind of advanced tools for smart grid operations. Thank you very much for your attention.
Thank you, Zeki. I would like to assure you that privacy and security are equally important. So if you have any privacy questions, related questions, please drop them online. I've seen already very nice, interesting questions. And now our final speaker in the panel, Bas Schreimer. He's the Director and Practice Lead of IT-OT Integration. So, Bas, for you.
Thank you, Alex. Yeah, thank you. Good. Bas Schreimer, working for TRC companies nowadays, but still doing the same digital grid operations and cybersecurity. 1 day a week I work in the nice Electro building together with Peter and Alex on the control room of the future, and there was a time I studied here as well. Briefly to Zeki, there will be something about, well, confidentiality in one of my slides, but I will point it out. And we're OT guys. So where's the privacy? We want to have safety and availability first. And in the IT, you want to have confidentiality and the privacy first. GDPR is very important, but OT is much more fun for us. And then a small other anecdote for Ethan of Siemens with the virtualization. So in 1992, I was a young engineer in ABB. And we got together to talk about future of protection and control. So they asked me, can you give this futuristic view? This was still in the time with Foley and with the overhead projector. So I came with a double optical fiber ring with remote I/O and sample measure value and 2 redundant central computers with software for protection and control. Can you imagine the discussion I had with my colleagues of 20, 30 years experience in the field, protection engineers? So I was burned down around the ankles because this is not what you do. From protection point of view, not. And my bosses said, but we earn money with selling boxes. There's only 2 boxes here. So now, 33 years later, it's good to see that we're moving into this virtualization. So Alex and I were together in Malta at the ISGT 2 weeks ago, and we had a discussion how to build the control system of the future. And Alex said, no, it's the control room of the future. I said, well, one doesn't go without the other. To have the system information in the control room and to run all the applications to operate the grid, you need both the room and the system behind. And we've been talking about the system. You even see a single line diagram there. And it's also not about just the grid, it's about the system operations. So both we need to control the grid and the system. What have we been talking about? Digitalization, process automation in electricity grids. So it's more process automation, it's increasing, and now we have technology that is much faster than in the past, and we have to use it all. It's data communication, real-time processing. It is quicker than we did in the past. It's still not the quickest that you can have. And then there's the cybersecurity topic that we are addressing and the resilience. Oh yeah, we need to keep the grids running because we like electricity. So this is the system on one slide. This is what we have built. This is what we are building. The top part is the SCADA real-time operations and the applications. And you see that it doesn't go all the way down to the low voltage grid because our SCADA systems were not designed for that. And we're adding so much more sensor technology in different systems collecting data. Did somebody say the attack surface is increasing? Well, here you see it. It's IT, IT for OT, OT and IoT. Internet of Things, I hope there's no internet in your substation, but we still use remote technology and communication. One thing is added here, data, structured data. If you want to run real-time systems, you need to structure your data to exchange it quickly and get rid of all the data conversion. SIM, by the way, the Common Information Model, IEC standard, we used to have computers with Intel inside. Here you have SIM inside and outside. Safety, availability first on the OT domain. And here's the IT. So many times use this slide to say that IT guys, you're there to support us. We earn the money on the OT side. And we have to learn to work together. And we're using much more IT in the OT domain. But then confidentiality, privacy is on the IT domain more than on the OT domain. But integrity was mentioned. If they start playing with our data here, then we're screwed as well. So, how does cybersecurity work on IT? This is quite consistent, even for international companies with their IT domain over several countries. There's quite a consistent way of protecting. OT, we already mentioned it. So many different areas, so many different technologies, so many different generations. I did not draw enough bubbles here to protect. And there's something new coming in our houses, behind the meter, next generation. Now we're going to run our house and have load shedding parts in our house. Oh yeah, to patch or not to patch, that's the question. IT to patch, OT, maybe not, probably not. Test it very well, there's so much, but you can have a patch management and you have this. Now we're coming to the real core. The secure IT-OT reference architecture for your systems. All the grid operators are working with accidental architecture. Yeah, maybe you don't want to hear it, but this is the truth. Everybody bought their systems, it all had to be put together, but there was no consistent structure and organizing for the data. This is all about a data machine. Eh? So you can structure that and you can migrate to that over time. A lot of work, not easy. What do you need? Security framework. Everybody has it now. NIS 1 already told us, NIS 2 is telling us to do more. Organization, responsibility, accountability, who's going to do it? You need orchestration over IT and OT. Who owns, who's responsible for what? You have to work together. And it's quite strict, actually, what you have to do. This is just a small list. If you don't know your assets, you don't know what to protect. If you don't know, it was a nice view just now of Mike. If you don't know your people, what they're doing, and it's not just the first level of awareness, it's also everybody in OT has to understand they're part of cybersecurity as well. So you have a program that you go through. The program never ends. Thank you. ISO 9000, no, sorry, but thank you, it never ends. I mean, you have to keep on going. So I'm giving you work. That's why I say thank you. The program never ends. ISO 9001, this is ISO 9001, but then not on the quality of your work, but on the security of your work. Only took 20 years to introduce and get ISO 9001 running smoothly. So, almost done. You see, structural approach. It's like a military operation. And you also see you need the technical standards, but without organization and the bosses telling you what you should do and pointing in the right direction and giving you the facilities, it's not going to happen. And here, the secure architecture, your reference, that you define, it's your Bible, but you also keep it up to date. So, now I'm coming to the conclusion. Cyber maturity. All the companies are doing business continuity already. Manage the risk, operational excellence, nothing new. Cyber needs to be part of that. The technical part, prepare, protect, detect, respond. If you cannot recover, they win. Oh yeah, and you have to report, says NIS. That's quite awkward, actually. And the people make it happen. They have to change their behavior, and this is us. And so we're all part of this, like a sports team. Practice, change our behavior, and work together. Somebody asked me this week, what is the good training to go to? I said, a training you do for yourself. Remember when you go to a training, you're there 3 days, you come back to work, loads of mails you have to go through, you completely forgot your training. How are you going to change? If you train with your team, then you can change. So train, there was a lot of training also from ENCS, train with your team. Be the security organization, that's all of us. So leadership, organization, culture, funding. If you don't measure, if you don't monitor, then you're not going to get anywhere. So, thank you. Now, thank you.
Thanks a lot, Bas. Thank you for the presentation. I would like to thank all the speakers in the panel for all their nice presentations. So thanks a lot once again. And drop your questions for the panel discussion a bit later. Now, I would like to introduce Arnaud. He's the program manager for energy transition at the Green Village. And Arnaud will tell us about the Green Village.
Thank you very much. Always great to be the last one for the break. So I hope you're still hanging in there. Welcome at the Green Village. As we've heard so far, or at least I was here the last 30 minutes, it's a lot about the big grid, the DSOs, TSOs. Obviously, there is huge risk and huge impact if something happens there in the cybersecurity domain. As a field lab for sustainable innovation, we thought let's add to this discussion the edge of the grid. So I heard something behind the meter. That's exactly where we play. Because lots of things can also happen there, and if that's accumulated, if you can steer 100,000 heat pumps, it will bother the grid also. So that's where we come into play. In a broader sense, it's a lab. It's a field lab, and it's a practical lab. So lots of the research that you've been here on the posters here are about fundamental solutions for fundamental problems. What we do here is to really work with systems that are out there now and test if they're cyber secure or not. That we do on different topics. And this is actually quite important to mention. So we've seen a lot of this, the theory, how can we solve it, how can we solve the simulations. And we try to do it on a very small scale with one setup to see if it's cyber secure or not. And then obviously you need to scale it up. The difficulties with TSOs and DSOs is that scaling up is suddenly the whole grid. But maybe we can think of doing that in cells and grow to a cyber secure future. So this kind of thinking might be relevant also for this topic. We look at the future energy systems and cyber secure energy systems. But we do that also in relation to buildings. And you see all kinds of sensors also in buildings that not necessarily relate to the energy system, but still can be an entrance to the energy system. So it's interesting to look at a bit more widely perspective. And we also look at climate adaptation and water. So the whole water domain with sensoring and stuff like that can also, for home energy management systems or home smart systems, can get into that energy system. So the problem is getting bigger and bigger. So yes, we are a lab, but we're also a place to connect. So lots of companies are testing their stuff here and they learn from each other how to tackle this problem, which is obviously very helpful for these companies to evolve. We also have a closed distribution system. And we never thought that would be a nice thing to have. But actually for innovation it's quite relevant because you can just test in our little loop here. If it breaks down, nobody cares. And if you have learned how to do it, then it's of course relevant to scale up to real mid-voltage stations, etc., etc. So suddenly it's an advantage to have this space, and also a space where we can experiment because we are accept to lots of rules. We just want to learn. It's a lab, so you can really do lab stuff in a real environment, and we think that's important to use with each other. If you then look at what kind of lab space do you got, so we've been working on energy hubs. So very complex behind-the-meter setups with lots of assets, with lots of cables, lots of communications, which all can be hacked, obviously, if you want to. So we created a lot of risk at the edge of the grid by designing these kinds of energy hubs. So it's interesting to look at that perspective. That's on, let's say, a neighborhood scale. You can also look on a home scale, really behind the meter, in the old-fashioned way of thinking about behind the meter. And then you have lots of new companies. So obviously it's an emerging market of steering those assets, and those companies not necessarily have a million years of experience in designing cyber-secure energy solutions. So this is one of them that actually with a hardware box tries to do that. But there are like lots of those companies starting, and we really want to help them to do it as secure by design. The whole charging thing is a kind of separate domain, but it isn't. So that's obviously also interesting to look at. And the whole storage domain, also on the edge of the grid, also becomes, if you look at risk and something, you heat it up too much, or the storage system itself is a high-risk component, which we are now adding to the edge of the grid. So obviously also very important to keep that secure. And DC grids is something where we've been working for the last 10, 15 years. I think it's picking up, especially also behind the meter. Let's do that also secure by design when we start to scale that up. We were thinking last year, how can we make this practical? Because we are a practical lab. It's not the big science, it's practical do stuff. So let's hack. And not hack by thinking, but hack by hacking. So we are organizing a hackathon, or Hack the Power Grid event, actually quite soon. I think the dates are on here. So next week, Tuesday, there's a masterclass on how to hack the grid. So if you want to do that, you're welcome. And then we're going to actually hack systems. So we got 4 suppliers of energy management systems to come forward with their OT-IT device, which is obviously very scary for them. So we applaud them that they said, we want to do that. And there will be like 30 hackers, 10 professional ethical hackers to try to hack those systems, and 20 students that want to learn to become ethical hackers. They're going to try to break in. And for us, it was all new, so I said, how does it work? I said, what happens if we find something, we first talk to the supplier. And we give them the ability to patch it, to solve it. But if it's solved, we're going to publish it anyway. I said, okay, that's quite a nice idea how to cope with this. So for us, it's new how hacking works. But I think very relevant, especially on the edge of the grid, where all kinds of devices from all around the world are being added to our energy system. We have also a new project that we're going to look at the mid-voltage station in our closed system here to see if we can make it more cyber secure. So that's for me a little bit of the explanation how we fit in the very big picture of today. Hopefully interesting to you. I heard that the next step will be a group photo. Is that right, Alex? Yeah. So up to you.
Great, thank you very much, Arnoud. So, if you are interested in hacking the power grid, please sign up. I know that we already teamed up with, for example, with Ricardo's researchers. So we have a team there. The researchers in the room, please team up, submit your registration, and let's see what comes out of it. Now, we will have a photo moment. After that, we will have lunch. I think we are quite on time, only 4 minutes late. So we are doing very well on time. Thank you very much again to all the speakers for nice presentations and keeping it brief and short. After the lunch, there is still time to register if you'd like. There are 2 labs visits for the control room, one at the lunch and one in the afternoon at the end, during the before we finish the event. So at the registration, you can there's a chance for you to sign up, and we can do the photo, yes?
Yeah, exactly. I guess just a very quick announcement. The launch will immediately follow, and I think we will do that in the room here. And as Alex already mentioned, he will be waiting for the people who sign up, and maybe ad hocly, so you can follow him to the future. So, yeah. And also, just thanks for the Arnoud for mentioning about the edge. It's a very nice hook for the afternoon, because nowadays you see lots of things happening on the edge, and in the afternoon we're actually talking about dive deeper into the edge of this whole thing. And of course we have a interesting kind of a panel, and also things about not just edge, but also about the AI in the edge, and also how does that actually go forward in terms of sustainability. All right, so I think in that sense, let's actually just socialize and have a very nice lunch session, and also, we should have actually Alex and also some of the folks who are taking us. Alex is coming, so we probably will already somehow maybe either go outside or here. Let's outside. Okay. Let's follow Alex together. Let's have a photo.